right, here we are, review sheet for our geometry test, which will be that open note test on Friday. Again, you might want to work on that optional outline of a reference sheet to store all your information in one place to make it a little easier to work with. We're going to go over page 1 of our review sheet now. So if the area of a circle is 144 pi centimeters squared, what is the circumference? So we're told area. I'll jot down area formula of a circle. The area is 144 pi. Substitute in for area, and we're going to solve for r. Divide both sides by pi. 144 equals r squared. Take the square root of both sides, which is 12. We're looking for circumference, which is pi times diameter. So if the radius is 12, the diameter will be 24. So circumference is going to be pi times 24, or 24 pi centimeters. So answer choice C. Okay. Number 2, determine the surface area of the following, which is a right triangular prism. If I look up my surface area formula, it's WH plus LW plus LH plus LS, where width and height are our dimensions of the legs of the right triangle. So I'm going to say the width is 4, the height is 3. L is the distance between the two bases, so right there. And then 5 is that slant, really our hypotenuse. So we go and we substitute in. So let's say 4 times 3 plus 8 times 4 plus 8 times 3 plus 8 times 5. 108 centimeters squared. So that'll be B. Okay. Number 3, fill in the blank. We're talking about our three-dimensional shapes. A hexagonal prism. Okay. So remember, a prism, it has those rectangular faces and then your named base. So here is a hexagonal prism. If we're counting its number of vertices, it's going to be 6 vertices on one base, 6 vertices on the other, so 12. Number of edges, 6 on one base, 6 on the other, and then 6 connecting. So it'll be 18. Square pyramid, we've got one right here. Number of vertices is going to be 4 on the bottom, 1 on the top, so 5. Number of edges, 4 on the base, and then 4 on the faces connecting up to the top, so it'll be 8. On number 4, we're identifying the solid of each that's formed from the net. Here, I can see all those points. They're going to make a pyramid. The bottom shape has 5 sides. It's a pentagon, so a pentagonal pyramid. Okay. B, I see 6 equal squares, so that'll be our cube. C, rectangle and 2 circles. That's got to be the cylinder. And then D, 2 triangles, 3 rectangles. That's going to be our triangular prism. Okay. Number 5, determine if the following side lengths form a triangle. Notice it just says triangle, not right triangle. We're just looking to see, does it form any triangle? So here we're going to use our triangle inequality. That A plus B is greater than C, where A and B are the smaller sides and C is the larger. So we'll set that up here on A. 6 plus 9 is greater than 15. 6 plus 9 is 15. Is 15 greater than 15? No, so it does not form a triangle. B, 8 plus 15, is that greater than 17? 8 plus 15 is 23, so yes, it is greater than 17. Yes, it forms a triangle. On C, 2 smaller sides, 20 and 22. Is that greater than 29? You bet. 42 is greater than 29. So yes, it does form a triangle. We're on the second page now, looking at our parallel lines cut by a transversal. Refer to the diagram below. Identify one pair of each of the angles. I'm going to identify all of them because I don't know which one you chose, but you just have to do one. So vertical angles, and here's my angle symbol, angle 1 and angle 3, 8. Those were little angle symbols. Supplementary angles, any angles that add up to 180. There's a lot here. Again, you just have to choose one. So we could have angle 1 and angle 2, and then angle 6 and angle 7. I think that's all of them. Alternate exterior angles, only two options here. Angle 1 and angle 7, or angle 4 and angle 6. Alternate interior angles, again, just two options, angle 2 and angle 8, or angle 3 and angle 5. Corresponding angles, remember those are angles that are on the same side of the transversal that we can slide back and forth and they're equal. We could have angle 1 and angle 5, and angle 3 and angle 7. Okay. Now on number 7, we're putting our angle relationships into practice. On A, we've got parallel lines cut by a transversal, 5x plus 15 and 6x. Those are corresponding angles, so they're going to be equal. So we'll set it equal to each other. 6x equals 5x plus 15. Subtract 5x from both sides. And we get x is equal to 15. Okay. 3x minus 15 and 2x plus 7, those are alternate interior angles so that I can see that they're equal. We also could have used a beach ball method on any of these two problems, right? Seeing the same shading are equal. 3x minus 15 equals 2x plus 7. I'll subtract 2x from both sides. X minus 15 equals 7. Add 15 to both sides. X equals 22. Okay. C, we have supplementary angles, which means they add to 180. So we'll do 3/8 x minus 1 plus 5/6x plus 0.3x. My first step equals 180. My next step might be to take that decimal, rewrite it as a fraction, so 3/10. So we'll do 3/8x, I'll also reorder, plus 5/6x plus 3/10x minus 1 equals 180. I gotta think least common denominator. Let's see from here, 8, 6, and 10. Least common multiple is 120. It's a big one, but that'll work. So we'll see. Let's see. 120 here. Let's see, times 15. 15 times 8 is 120. So that's going to be 45. 6 times 20 is 120. 5 times 20 is 100. And then let's see, we're going to do times 12 times 12. 3 times 12 is 36. Now I'm thinking team game up top, right? We're just adding them up. 45 plus 100 plus 36 is 181. So that's 181 over 120x minus 1 equals 180. Add 1 to both sides. Okay. That gives us 181 over 120x equals 181. Eliminate the fractional coefficient. We have to multiply both sides by the reciprocal, which will be 120 over 181. Cancel, 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 cancel. We get x times 120 over 181. Our 181s cancel, and we get x is equal to 120. Got some 2D geometry going here on page 3. Leave our answer in terms of pi for the circle below. We're going to find area and circumference. From looking at the image, I can see the radius is 8, so diameter would be 16. So our area pi r squared is going to be pi times 8 squared. So 64 pi. Remember, we still need our unit, 64 pi centimeters squared. Circumference is pi times diameter. So that's going to be pi times 16, 16 pi centimeters. And our next one, we're rounding to the nearest tenth. We'll have to multiply. I can see the diameter is 16, so the radius will be 8 pi r squared. Oh, this is actually kind of a boring problem compared to the other one. I apologize for that. So we're really just taking what we had in terms of pi and making it not in terms of pi, finding the actual area. Let's see, that's going to be 201.06, so round to the nearest tenth, 201.1. 201.1 centimeters squared. Our circumference, like we saw before, pi times diameter, is going to be 16 pi. We'll multiply by pi. Is going to be 50.26, so 50.3, 50.3 centimeters. We're looking at number 9 on our review sheet. Find the area and perimeter of the following figure, round to the nearest hundredth. This problem's a little deceptive in its challenge level. It looks sort of like an old geometry problem. Area of the semicircle, area triangle, perimeter, circumference, good to go. But let's see how that changes as we get going. So let's start with our area, and we'll start with our semicircle. Area of our semicircle is going to be pi r squared divided by 2. We can see given to us in the diagram is the diameter 12, so the radius would be 6. So our area equals pi times 6 squared divided by 2. So that'll be 36 pi divided by 2, or 18 pi. As we multiply by pi and round to the nearest hundredth, we get 56.55 for our area of the semicircle. Now let's get our triangle, where our area is going to be 1/2 base times height. Base and height are always perpendicular, making that 90-degree angle. So our base is 12, height is 14. Which gives us an area of 84. And last thing, we're just going to add them together. 84 plus 56.55 gives us a total area of 140.55 centimeters squared. Okay. So first thing we want to look at with our perimeter, we want to remember that it's that distance around the outside. So it's going to be around that circumference of the semicircle, and then our two sides of our triangle here, and that's going to be an isosceles triangle. Notice we didn't go through the middle, so that 12 is not going to be included in our perimeter because it's inside of the figure. It's not on the outside. Okay, now what we have to realize here is we don't know the side length of this triangle. It's not given to us. So, you know, you might have said, oh, well, we don't have enough. What's wrong with it? No, we can figure this out now. This triangle really is split into two equal right triangles. So we've got it right there. If I outline it for us, we've got a right triangle here. And I'm just going to kind of pull that right triangle out, draw it over here. Okay. And we can see one of the legs of our right triangle is 14. Our hypotenuse is the unknown over here. Okay. Then we need that other leg. That other leg is half the diameter, half the base of the triangle, so it is 6. Now we can use our Pythagorean theorem to solve for x. 6 squared plus 14 squared equals x squared. So 36 plus 196 equals x squared. That's 232 equal to x squared. Take the square root of both sides, round to the nearest hundredth, and we're going to get x equals 15.23. So that means this side of the triangle is 15.23, and this side of our triangle is 15.23. Now we just have to find the circumference of our semicircle. So that's going to be pi times diameter divided by 2. So pi times 12 divided by 2, or 6 pi. And when we multiply by pi, round to the nearest hundredth, 18.85. Now to get our perimeter, we're just going to add the circumference plus the two sides of the triangle. So 18.85 plus 15.23 plus 15.23 gives us 49.31 centimeters. There we go. Okay. Number 10, a little easier of a area and perimeter figure there. Again, we have a semicircle and a square. So our semicircle, pi r squared divided by 2. We want to realize the base of the square is also the diameter of our semicircle, 16. So our radius is going to be 8. So area equals pi times 8 squared divided by 2, or 64 pi divided by 2, which will be 32 pi. We're rounding to the nearest whole. Which is 100.53. So we'll say that that's 101 for our area of our semicircle. And then we need our square, where the area is the side length squared. And we have that side length of 16. So that'll be 256 once we do our 16 squared. So then just our total area, 256 plus 101. Right, that's going to give us a total area of 357 inches squared. Okay. So again, let's kind of think of the perimeter of this figure. It's the distance around the outside. So we're going to have that circumference of our semicircle and then 3 of the sides of our square. Right? We're not going across that middle fourth side. It's just those 3 sides of the square. So let's find our circumference of our semicircle. Circumference equals pi times diameter divided by 2. So pi times 16 divided by 2, which is going to give us 8 pi, which will be, when we find out, 25.13, so rounded to the nearest whole, 25. So that'll be 25 plus our 3 sides of 16. So 25 plus 48, 73. Okay, so 73 inches for our perimeter. We're going to look at some of our 2D geometry word problems and then some simplifying squares and cube roots. Okay. Perimeter of a square is 48 meters. Determine the area. Well, we should know perimeter of a square is 4 times the side length. So 48 equals 4s, our side length. Divide both sides by 4. We get that our side length is 12. Area of a square is side squared, so 12 squared. 144, so 144 meters squared. If a circle has a circumference of 12 pi, find the area to the nearest hole. Nice. Circumference pi times diameter. We're told the circumference is 12 pi, so we'll substitute that in. Solving for d, divide both sides by pi. 12 is equal to our diameter. Now we're going to go find the area, pi r squared. If the diameter is 12, the radius is 6. Pi times 6 squared. It's going to be 36 pi, but we're rounding to the nearest whole. 36 times pi is 113.09, so 113 feet squared. And there we go. Okay. C, if a circle has an area of 44 meters squared, then find the radius, round to the nearest 10. So area equals pi r squared. 44 equals pi r squared. Actually, I have to divide by pi this time because it's not in terms of pi. we got 44 divided by pi. That's rounding to the 14.005. We're going to call that 14. Square root of both sides. Let's see, square root of 14. 3.74, so rounded to the nearest tenth. 3.7. 3.7 meters. F. Find the base of a triangle with an area of 36 meters squared and a height of 4.5 meters. Area is 1/2 base times height. Area is 36, so that's going to be 1/2 times x times 4.5. Okay, so 36 is equal to half of 4.5 is 2.25. So we got 2.25x. Divide both sides by 2.25. And we should get 16 is equal to x, or our base. So a base of 16 meters. On number 12, we're looking to simplify our imperfect square and cube roots. So I want to think about my memorized list of perfect squares and perfect cubes as we go and do this. So the largest perfect square factor of 50 is 25. So we've got 25 times 2. Square root of 25 is 5. So that's going to be 5 rad 2. On 216, I'll probably go and check. My guess is 64. Oops, 64 doesn't work. Maybe it's 36. Yeah, 216 is 36 times 6. Square root of 36 is 6, so that's going to be 6 rad 6. A way I can check and make sure that I fully simplified is I look at my radicand 6 and I check, oh, are there any perfect square factors of 6? No, so that means I've fully simplified. Okay, 4 rad 27, that's a coefficient of 4, so 4 times the square root of 27. The largest perfect square factor of 27 is 9, which would be 9 times 3. Square root of 9 is 3, so that's going to be 4 times 3 rad 3, so 12 rad 3. Okay. We've got 5 times the square root of 24. Largest perfect square factor of 24 is going to be 4. Right, so that's going to be 5 times the square root of 4 times 6. Square root of 4 is 2. So 5 times 2 rad 6, which would be 10 rad 6. Okay. Now we're moving on to our cube roots. The largest perfect cube factor of 108. Of 108 is 27. That's 27 times 4. Cube root of 27 is 3. So that's going to be 3 cube root of 4. Okay. And we've got 4 times the cube root of 250. The largest cube root factor of 250 is 125. Cube root of 125 is 5. So that's going to be 20 cube root of 2.